Hi friends, welcome to my channel. Let's have a look at problem 1352, product of the last key numbers. In this video, we're going to give a solution based on a modified product, partial product sequence. 这个冰箱真是响的是时候。
那不挺好的吗？你要是在那个。
啊？
那不挺好的吗？
为啥？
那你要是录了中间的响，你不就白录了吗？没啥话说的，你还能你让。
行了，别说了。
你让你儿子可以不说话，你让平常不讲话。
Hello friends, welcome to my channel. Let's have a look at problem 1352, product of the last key numbers. In this video, we're going to share a solution based on partial product. So first, I'll read through the statement to digest the requirement, and then we give an analysis, and finally we share the code. So we are required to design an algorithm that accepts a stream of integers and retrieves the product of the last key integers of the stream. So we are required to implement the product of numbers class with the following methods. So the first one is a product of numbers, which is an initializer. And the second one is an add method, which appends the integer num to the stream. And the third one is get product, returns the product of the last key numbers in the current list. So we can assume that always the current list has at least key numbers. So the test cases are generated so that at any time the product of any contiguous sequence of numbers will fit into a single 32-bit integer without overflowing. So here are one examples, right? So you can digest this according to the explanation. So before we do the analysis, let's also look at the constraints. First, the num is bounded below by 0 and bounded above by 100. So in this problem, actually, the 0 plays a special role. Secondly, the key actually is between 1 and 4 times 10 to the power 4. So the third one is about the frequency of calls. So at most 4 times 10 to the power 4 calls will be made to add and get product methods. Lastly, the product of the stream at any point in time will fit in a 32-bit integer. So with that said, we are ready to look at the analysis. So here our method is based on partial product. So this is similar to partial sum. However, we need to deal with the zero problem. So if there is any zero among the key integers, so the product is 0. So this is a simple observation, but will play an important role. First, let's look at the partial sum. So for example, if I have a list given by capital A, so the partial sum ending at index I is the sum of all elements with index less than or equal to I. Let's use this convention. Then we can write Sg, right? So if we compute Sg minus Si, so this is nothing but the element sum starting from index I plus 1 and ending at index j. So this is for partial sum. So now let's look at the analogy. So for partial product, so if we define Pi to be the product of elements with indices less than or equal to index I, then we have Pi. Similarly, we can write Pj. So we can assume j is larger than I. Then if all the elements are non-zero, then we can compute Pj over Pi, right? So because if we want to use division, this Pi shouldn't be 0. So in this case, we're going to have the product of elements starting from I plus 1 and ending at index j. So this is a simple idea. However, when there are zeros, the above reasoning for key products shall be adjusted by length. So if we meet a 0 in the stream, so we reset the data storage list to be 1. So here we set 1 because if we just have one element, so for example 5, then we are going to append 1 times 5, then 5 divided by 1 is 1, so we get the nearest product of single elements. So you can make a generalization for this reasoning. So otherwise, so we're going to append the last data in the stream times the current num. So this way, if we look at it as a process, this will store pieces of partial products, right? So this is the this is the modification for this problem. Then to compute key product, so we should check the length. If the length of data is less than or equal to k, in other words, among the k nearest or latest data points, there are zeros instead. So it means that we need to return a 0. Otherwise, we use partial product to return data -1 divided by data up to previous time -k minus 1. So this way, we get the k element product like here, right? So because the index difference for -1 and -k minus 1 is k, so we get k products. So this is the main idea for this problem. As for the implementation, it's sort of verbose. So first here, let me initialize the data. So the data to be 1, and the length also we want to use a length attribute to be 1. So this is the initialization, right? So you can actually, this part is not absolutely necessary, because finally we can just use length self data. However, if we put this here, it brings some convenience. And then we want to do the add. As we mentioned, so we want to check if the number we meet is 0 or not. So first, if num is 0. So in this case, so we're going to reset the data stream to be 1. And also, we are going to reset the length to be 1. Otherwise, so what we are going to do is self data append. So we are going to append data -1 times the current num, right? So this way, as a process, if we continue, so we are going to get partial sum, partial product segments. Then in this case, length should be incremented by 1. So this is the add method. So that's actually the key logic together with the way we get the key product. So in order to get a key product, we need to check the length, right? So if length or self length, this attribute is less than or equal to k. So in this case, it means that among k recent or latest numbers, there are zeros. There are at least 1 0. So we're going to return 0 in this case. Otherwise, so we're going to return self data -1 divided by self data -k minus 1. So here we want to point out, here we should use integer division in order to confine to the data type. So with that said, I guess that's a full format of solution to this design problem. So now let's do a check. So data is not defined. So here, self data. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the test cases. So I guess that's about it for this problem. So in this video, we used a modified version of partial products to do this problem. In short, so we are going to track the partial product segments and then check if the segments have length larger than k or not. If less than k, it means among the recent k numbers there are zeros, we return 0. Otherwise, we use the product partial product quotient, right? So that's it for this video. Thank you.